Okay, this is homework for Wednesday, April 20th. You're doing page 32, number 2. So number 2, this is my dog because it's her birthday today. And she's sitting here right in front of me, waiting for me to be done so that I can take her on a walk or go play with her toys. So here's her little birthday hat. She's 9 years old today, so I'm going to say happy birthday. That's my Jersey girl. So I thought I'd put a picture in there for you. Okay, anyways, number 2 gives you different situations or different plans that go along with the homework that we did yesterday. So I want you to do the same exact problems A through D, but with these 2 new plans. So I have 2 plans now. This one is $1 per game, but $4.50 to get in, or $1 per game and $3.50 to get in. And A tells me to write 2 equations for each plan. So plan 1, my slope, since it says per game, is 1. So y equals 1x plus $4.50 to get in. And then plan 2 is y equals 1x again, because $1 per game, plus $3.50 to get in. Okay, I hope right away you guys notice something. Because B says to make an estimate of the coordinates of the intersection point. So you're thinking, when will they meet? When will the amount of games and the cost be the same? But Ms. Steffen's always telling you to look to see if there's any shortcuts or any tell signs that you don't have to do some work. Right away you should notice that these 2 equations have the same exact slope. And with all that we've learned the last couple weeks, you should know that when 2 lines have the same slope, so let me draw this for you, and a different y-intercept, that means they're never going to cross. So like plan 2, the y-intercept is $3.50. So I'm going to say that's like right here. Okay, this point right here is $3.50. But then plan 1 has a y-intercept of $4.50, so it's 1 more up, but it has the exact same slope. So I'm trying to get these parallel here. I might not be able to. That's good enough. So this is at $4.50. So since they have the exact same slope but different y-intercepts, they will never cross. So you didn't have to make an estimate because there won't be an intersection point. So I'm going to write for B, there will not be an intersection point. Lines have no solution. Okay, so I didn't have to do any work for B besides write that they will not intersect. Okay, for C is when it wants us to algebraically actually solve for the intersection point. So we know there's not going to be one, but we still need to show our work. So I had 1x plus $4.50, and my second equation was y equals 1x plus $3.50. Since both of the equations are equal to y, that means I can set them equal to each other. So I can do 1x plus $4.50 and then equals 1x plus $3.50. Okay, I want to get x onto one side, so I'm going to subtract 1x over here, subtract 1x over here. Those cross out. But then 1x minus 1x is also 0, so I'm left with $4.50 equals $3.50, which is not true, which is why it's no solution. No solution. Okay, So then D says, for what number of games would plan 1 be a better deal? Well, looking at the y-intercepts, if I play 1 game with plan 1, I owe $4.50 plus $1. So I owe $5.50. If I play 1 game for plan 2, I owe $4.50. If I play 0 games for plan 1, I owe $4.50. If I play 0 games for plan 2, I pay $3.50. So no matter what, plan 2 is better. So playing more than 0 games, plan 1 is not good. Plan 1 is never better. So it says, for what number of games would plan 1 be a better deal? I'm going to say plan 1 would never be the better game, because at 0 games it costs $1 more than plan 2. So plan 2 would always be the better deal. Alright, that's your homework for tonight. I will see you tomorrow.